All right, let's solve these problems, people. Here's number one. I've got a 22 kilogram sled on this hill. First thing is, what is the acceleration? The acceleration down the hill is equal to g sine theta minus g cos theta mu. All right? Now, the mu on this sled right here is 0.14. Its friction on the ground is 0.14. So I'm going to say acceleration down the hill is equal to 9.8 sine 23 minus 9.8 cos 23.14. I'll punch this into my calculator. 9.8 times 23 sine minus parentheses 9.8 times 23 cos times 0.14, close the parentheses, equals, I get 2.56 meters per second is my acceleration down the hill. What force would be needed to hold it still? So if I'm standing here pushing up, trying to keep these kids from sliding down the hill, how hard would I have to push? Well, I'd have to push with something equal to their force coming down the hill. So here we can just say F is equal to MA. It's trying to slide down the hill only with 2.56 acceleration, and the mass is 22. So the force down the hill is just 2.56 times 22. F equals MA, 56.4 newtons is how hard you have to push to keep it from coming back. How long would it take it to slide down the hill? We know the hill is 50 meters long. XF equals 1/2 AT squared. The acceleration down the hill is 2.56, 1/2, 2.56 times t squared, and the distance of the hill is 50 meters. So I'm going to solve for this t squared. So this will be 50 times 2, right, divided by 2.56 square root. That's how we get all the way down to the t. So I'm going to say 50 times 2 divided by 2.56 equals square root 6.25 seconds. It's going to take it 6.25 seconds to get to the bottom of the hill. What would its maximum velocity be? Well, if we start at 0, and acceleration is equal to change in velocity over time, right? Well, we have 6.25 seconds to go. So 6.25 seconds, and we speed up by 2.56 meters per second. Every one of those, we get a final velocity times 2.56, 16 meters per second. The next problem, we're pushing a refrigerator. What is the resistance force of this refrigerator? The fridge is 43 kilograms. The mu is 0.14. Well, acceleration towards the ground is 9.8. So the total resisting force of the refrigerator is really just its weight times its mu. So 9.8 times 43 times 0.14. It can resist with 58.9, or we're just going to call that 59 newtons. That's its resistance force. It doesn't want to slide with that much, okay? Will it move if you push on it with 200 newtons? Yeah. If it's resisting with 59, but you're pushing it that way with 200, then you definitely have more force in the direction to the right. What will the acceleration be? Well, let's find the leftover forces. 200 minus 59 means that we have 141 newtons left over that way. What's the acceleration? We'll just say F equals M A. 141 equals 43 times A. 141 divided by 43. 3.28. 3.28 meters per second per second. Number 3. What is the velocity? Well, we need to find out. This thing's turning 33 RPMs. So it's doing this 33 times in a minute. We need to find out the distance around that it's going, all right? That's pretty simple. The circumference that it's going is equal to 2 times pi times r. The r is 10 centimeters, so that's 0.1 meters. So it's going this far, right? And it's doing it 33 times for every 60 seconds. So that's it turning 33 RPMs. So 2 times pi times 0.1 times 33 divided by 60 seconds. Its velocity is 0.34 meters per second. What is the acceleration? Well, as this thing goes around, it's going to be circulating. So we're going to have a centripetal acceleration. AC equals V squared over R. 0.34 squared over 0.1 meters. So there's our 0.34 still there, squared, divided by 0.1. 1.19. 1.19 meters per second is this acceleration. What mu would we need for this thing not to fly off? Well, gravity is what's holding it down, gravity and the mu. So gravity times the mu would have to be equal to 1.19 at least. So to solve for the mu, 1.19 divided by 9.8. That gives us 0.12. So the mu needs to be at least 0.12 or greater for it not to fly off. Would a 0.11 mu be okay? No. What would be the motion when this thing slid up? It would keep going straight. What velocity is needed to go around this upside down without falling? We know that the acceleration due to gravity on Earth is 9.8 meters per second. So we need to make sure our acceleration around the circle is 9.8 meters per second. So our centripetal acceleration is V squared over R. So we need at least 9.8 equal V squared over the radius. The total height of the loop is 0.88. So the radius is only 0.44. So we're going to solve this. We're going to say 0.44 times 9.8 square root will give us V. 0.44 times 9.8 equals square root 2.07. 2.07 meters per second is the needed velocity. All right? That's what we need. Now, some of these problems may look just a little bit different than yours, or something might be a little bit different, but let's do it. We have a 13 kilogram car going around a 21 meter radius circle with a mu of 0.81. What's the maximum acceleration? The maximum acceleration, gravity is holding the car to the ground, but it can only do it with 81% of itself because that's the mu. So 9.8 times 0.81 is the best we can do. So we would say 9.8 times 0.81, boom, 7.94 meters per second is the best we can do. What is the maximum velocity we could get? Well, if our best centripetal acceleration is 7.94 meters per second, then that's the best V squared over R we can do, right? That's the best we can do. 7.94 times 21 square root will give us V. 7.94 times 21 equals square root. 12.9. 12.9 meters per second. That's the fastest we can go. What is the maximum force the tires can apply to the ground? Well, our maximum acceleration is 7.94 because this is all the traction we have. F is equal to ma. So the mass of the car is 1,300 kilograms. The best acceleration we can do is 7.94. So 1,300 times 7.94 equals 10,322 newtons is the best the tires can apply to the ground. Any more than that, and the thing slides out. Last problem here. We shoot this object at 11 meters per second at 49 degrees. How long will it be in the air? Well, first thing we would want to do is find the velocity on this angle. So this is the opposite, and that's the hypotenuse. So we'd say the sine of 49 is equal to the opposite side, that's the upside, over 11. So 11 times the sine of 49. So 11 times 49 sine equals 8.3 meters per second is like the initial velocity this way. Now we know gravity is working against it at 9.8. So we need to figure out how long it would take it to get to the top. Acceleration equals change in velocity over time. The acceleration is 9.8. The change in velocity is 8.3 because it's going to go from 8.3 to 0. How long would that take? So we end up with 8.3 divided by 9.8. 8.3 divided by 9.8 means it takes it 0.85 seconds to get to the top. How long is it in the air? Twice that long. 0.85 times 2, or 1.7 seconds. Okay? So 1.7 seconds is how long it's actually traveling sideways. All right? What's its maximum height? That's easy. We're going to use the shortcut formula. XF equals 1/2 AT squared. We know the acceleration down here is gravity. So 1/2, 9.8, and the time it takes us to go up is 0.85. 0.85 seconds squared. So 0.85 squared times 9.8 divided by 2 equals 3.5 meters. 3.5 meters is our maximum height. Where will it land? How far away will it go? All right? We got to find this velocity. If finding this was the opposite, we used the sine, we got to use the cosine here. So down here, the cosine of 49 is equal to the adjacent side over 11. So 11 times 49 cos. 49 cos times 11 equals 7.2. We're moving sideways at 7.2 meters per second. And how long do we do that? For the total time it takes to go up and down, so we're going to go all the way over here, times 1.7 seconds. We're going to let 12.27 meters away. I hope that this all makes sense to you. I realize I slid that out of the way. There's a good shot of all the math if you need it.